support vector machine is one of these algorithms that I really like. Well, for one thing, the name is cool. Support vector machine. I like that. And the second thing is it's actually quite versatile, and I found it personally to be very useful for a lot of geological data sets. So let's look at the principle behind support vector machine. Again, imagine that you have a feature space where you have two vectors, and in this case we'll just look at the classification between two different classes, the gastropods and the quartz crystals. Now in my example, the two classes are well separated, so that's not always the case in reality, but for illustration purposes, that is a good way to represent it. So now between these two classes, we can actually fit some regression lines. In fact, we can fit two regression lines, the two green lines here, and you can see that these lines are basically defined by two instances of each class. These are the instances in this particular data set that define where the lines are. So the support vectors are very important. Now, for classification purposes, the goal of SVM is to maximize the distance between these two lines. Now, the distance between these two lines is known as the street. So you want to maximize the street when you do classification. That's known as SVC. So you can turn your lines and then you choose different support vector. And in this particular case, the largest street, so where you have the biggest distance between the two classes, is represented by these two support vectors. If you do regression, you try exactly the reverse. You try to minimize the distance on the street. So SVR, or support vector regression, tries to minimize the distance between the two support vectors. So you can see how versatile SVM is. Support vector classification, SVC, and SVR, support vector regression. Both are essentially coming from the same principle, but in one case we try to minimize the distance between points. In the other case, we try to maximize that distance. Now there's a few subtleties about SVM, or SVC and SVR, that are interesting to consider. So the first thing is that a very good thing about SVM is that it's not that sensitive to outliers. So imagine that I add here an outlier point. It actually makes no difference to the classification. Why? Because the support vector are still the same. However, if you add a sample that is on the street, you can see that this changes the support vector because, of course, the separation between the two classes is now different. And the cost function that is used for support vector machine is this one. It's actually a logistic, it's very similar to a logistics cost function, and it adds a cost if the distance between the street edge and the sample is greater than 0. Otherwise, the cost is 0. And this is why outlier have no impact on support vector machine. But I would encourage you to try SVM for your regression and for your classification problems, because for small data set, which, let's face it, for many geoscience problem is the case, SVM outperforms, in my experience, some of the random forest or decision tree algorithms. So it is a very useful algorithm to have in your bag.